In the second half of section 2.1, we're going to look at some word problems involving the tangent ratio. In our first example, we have south-facing solar panels on a roof work best when the angle of inclination of the roof, that is the angle between the roof and the horizontal, is approximately equal to the latitude of the house. The latitude of Fort Smith, Northwest Territory is approximately 60 degrees. Determine whether this design for a solar panel is best for Fort Smith. Justify your answer. Okay, first thing we need to do is we need to figure out the angle of incline. And in this particular diagram, the angle of incline would be the angle right here between the solar panel and the horizontal. Therefore, we're going to be using the tangent of some angle theta is going to be equal to the opposite side, which is 9, divided by the adjacent side, which is 12. And just like we did earlier, I take tan inverse of both sides. And if you go to your calculator now and go second tan, you get 36.9 degrees. So therefore, this would not be a good example. This would not be a good house for solar panels because the angle of incline is only approximately 37 degrees and the latitude of Fort Smith is 60 degrees. So this is not a good design for solar panels. Okay, in our next example, we have a ladder leans against the side of a building. It reaches 10 feet up the side of the building. The bottom of the ladder rests 4 feet from the base of the wall. What angle to the nearest degree does the ladder make with the ground? Okay, so we really have to read these questions carefully. And we are asked to figure out what angle to the nearest degree does the ladder make with the ground. So we want to draw our diagram. So there's the ground, there's our wall, and here's our ladder. And it says that the ladder reaches 10 feet up the side of the wall, so that's 10 feet. And it says the bottom of the ladder rests 4 feet from the base of the wall, and the angle of incline is going to be that angle right there. So therefore, the tan of theta is going to equal opposite, which is 10 divided by 4. Again, we'll take the tan inverse of both sides. And if we go to our calculator and do the tan inverse, you get 68 degrees approximately if you round off to the nearest degree. So therefore, because we're doing a word problem, we should answer the problem with a statement. So we would say the ladder makes an angle of incline of 68 degrees with the ground. Okay, for a little bit of enrichment here, the question is now asking how long is the ladder, okay? And right now, the only tool that we have that could help us do that would be Pythagoras' theorem. And again, we have our information that this is 4 feet and this is 10 feet. And we want to find the length of the ladder, which we'll call x. So therefore, we could say that x squared is equal to 4 squared plus 10 squared. So 16 plus 100 is equal to x squared. Put it up here. So therefore, x squared is 116. And if we take the square root of 116, we actually get plus or minus 10.8. But again, length can only be positive, so therefore the length of the ladder would be approximately 10.8 feet. Okay, next example is one for you to try. So I'll give you a second to pause the video, read the question, draw a diagram, and see if you can come up with the answer. Okay, in this example, it says we have a support cable is anchored to the ground 5 meters from the base of a telephone pole. So there's my telephone pole. And there's the ground. And it says that the cable is anchored to the ground from the base of the pole 5 feet or 5 meters away. So this is 5 meters. And the cable attaches up 17 meters up the side of the pole. So that means that this distance here is 17 meters. And we're asked to find the angle to the nearest degree the cable makes with the ground. So again, we're looking for the angle of incline. So again, I'll start with my tan ratio. The tan of theta is 17 over 5. Therefore, theta is tan inverse 17 over 5. Should make that look like a 5, not an 8. So therefore, they want us to round to the nearest degree. So if I go tan inverse of 17 over 5, this is approximately 74 degrees. Again, we would say the angle of incline is 74 degrees. So we have a final statement. Okay, taking a look at this last example, it says a support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long and it's attached near the top of the pole. What angle to the nearest degree does the cable make with the ground? Okay, so let's draw this situation. So again, it's 5 meters from the base and the cable is 19 meters long. So the cable is attached to the pole and the cable now is 19 meters long. And again, we want to find this angle and we want to find the angle of incline using the tangent ratio. Well, I encourage you to pause the video, give this some thought, and see if you can come up with a solution to this problem. Well, hopefully you've had a chance to tackle this problem. And if we look at the angle we're trying to find, the angle of incline, to use the tangent ratio, I need the opposite side and I know the adjacent. So the first thing I need to do is I need to find this missing side right here. So what I'm going to do is I'm going to use Pythagoras' theorem. And again, you have to be careful with Pythagoras' theorem because we are given the hypotenuse. This is the side we're looking for. So therefore, the hypotenuse squared equals the sum of the legs squared. And I'm going to call the missing side x just to give it a variable. So 19 squared is 361 is equal to 25 plus x squared. If I subtract 25 over, I get 336 is equal to x squared. And if I square root 336, I get 18.3 is equal to x. So this side here is approximately 18.3. Now I can use my tangent ratio because the tan of theta is 18.3, the opposite side, over the adjacent, which is 5. So therefore, theta is going to equal tan inverse of 18.3 over 5. So therefore, second tan 18.3 divided by 5. And this works out to be approximately 75 degrees. So again, the statement, the angle of incline is approximately 75 degrees. Okay, that concludes the problem section for section 2.1. So there's your assignment for today. For question number 21, you need to know what an isosceles triangle is. So you may have to look that up and search it up on the internet if you're not sure. I'll let you explore that concept on your own.